All right, guys, I just wanted to make a video talking through our Unit 7 Part 2 test. I posted my answer key up on Classroom so you could take a look at it. Again, you'll notice my answer key is a little bit different of just a format than your test was. I had done my answer key before we had put in all the multiple choice possibilities, but you can see that the answer does have the multiple choice answer on there as well. So again, go through and look at your submitted pictures that you put on Classroom. I made some comments on there. It should hopefully on your end highlight it kind of where I made it. So that way, if you see where the comment shows up, it'll show you which problem, which question I'm looking at. This is kind of one of the first times I've really done the highlighting on there. So let me know if you can't tell on there. But a few things I was looking for. Your work did have to match your answer. I had a few people that the work was totally wrong, but they somehow magically got the right answer out of it. So points, extra points did come off of that. So again, the answer itself that you submitted on the Google form, the multiple choice, was really one of the 2 or 3 points per question, and then the rest of the work was the other points for it. So I was looking at your work, I was looking that your work matched it and everything. So that's something moving forward that I want you to be cognizant of. Make sure that your work matches it. Make sure that your work is thorough. So problems 1 through 8 were actually out of 3 points, and then 9 and 10, since those were a little bit less kind of labor intensive, the way that we had our multiple choice answers written, those were just 2 points. So 1 point for the answer and 1 point for the work. Otherwise, 1 through 8 were 1 point for your answer and 2 points for your work that matched. So just to go through and talk through a few of these here. Number 1 was pretty decent overall, I would say. Most people divided by 2 right away. And the big thing that I saw that was missing from a lot of homework, or I'm sorry, a lot of the work that you guys submitted was really, oops, I didn't mean to cross it off there, really this work right here in changing your window on there. So I want to make sure that you are actually going through and changing not necessarily your window, but your interval on that. So really when you're solving for this, yes, you get pi over 6 and 5 pi over 6, but a lot of people left that and then subtracted 11 pi over 6 and got some negative answers. Again, your final answer should always be between 0 and 2 pi here. So that's one thing that you want to make sure you're aware of on that. So what I did when I went through it is I got pi over 6 and 5 pi over 6, but I crossed those off because those were not between the two new numbers for our interval. I added 11 pi over 6 to everything, so the x plus 11 pi over 6 has to be between 11 pi over 6 and 23 pi over 6. So that means I had to find the coterminal angles. I added 2 pi here. And that gave me 13 pi over 6 and 17 pi over 6. Then I subtracted the 11 pi over 6 to get those two answers there. Number 2, this one we didn't have to change the interval, but we did want to go through and use our identities. So you would have noticed that we had a cosine and a sine in the problem. So really when you have something like that, that's kind of your clue that you're going to want to use your identities on there. So you had a cosine of 2x. So I replaced that with the 1 minus 2 sine squared. Now on your identity sheet, there's a number of different things that the cosine of 2x you could set have it equal to, but I chose that one because I wanted it to have another sign in there. So now that we have that, we notice that we have a quadratic, so I set them equal to 0. I just moved it all to the right to keep the 2x squared, to make the 2x sine of x squared the 2 sine squared of x positive there. And now that means I can factor it. I had a few people kind of fumble on the factoring here. Don't forget that one type of factoring is greatest common factor. So we have the sine of x times the 2 sine of x plus 1. Then we can set them both equal to 0. I had a few people forgetting about the sine of x equals 0 as well. Again, some people were trying to just divide by sine. We want to factor it out because that gives us our two answers of 0 and pi, along with the 7 pi over 6 and 11 pi over 6. And a number of people that didn't have that part of it and it didn't match their answer. I think some people got the answer of A because they're like, well, I guess it has to be with those other two. But again, I am looking for your work to match that just since we did multiple choice on this round here. Number three, once again, we have a sine and a cosine, so that's kind of your clue that you're going to want to make sure that you adjust your and use your identities here on this one. So I replaced the sine squared with 1 minus cosine squared. And then multiplied it all the way out. And once again, we get something that can factor. So this one is a trinomial, so I factored it like a trinomial. We get the cosine of x is 1/2 and the cosine of x is -1, and that's what gave us our answers. Number four, this one actually, I had a number of people miss because they did not change that interval over here. Again, you want to think about changing that interval. Because it was an x over 2, we can't have both answers on that. So if we're doing x over 2, we're going to divide that interval by 2. Now, right here, we are only looking at the pi over 6 because that number is not in this interval here. So now we multiply by 2 and we get that pi over 3. So be careful. I had a lot of people with the other answer on there. Number 5. All right, for this one, what I had a few people doing was thinking that they could distribute cosine. This is not distributive property. That pi over 6 plus x on there, that's not something that you can just say, okay, that's the cosine of pi over 6 plus the cosine of x. It is not multiplying, so it's not distributive. Instead, we used the sum identities. Both of them were sums. That's why I used the sum identity on there. So the cosine of that pi over 6 plus x, that's this part right here. Again, straight from the identity sheet. The identity sheet had, I think, cosine of a plus b. It was the cosine of a times the cosine of b minus the sine of a times the sine of b. And then this part right here corresponds to all of this right here. So again, that was the sine of a plus b is the sine of a times the cosine of b plus the cosine of a times the sine of b. So what happens there is now we can go through the cosine of pi over 6 is root 3 over 2, so times the cosine of x. The sine of pi over 6 is 1/2, so we have minus 1/2 sine of x. Right here, sine of pi over 3 is root 3 over 2 cosine x. Cosine of pi over 3 is 1/2, so we have 1/2 sine of x. So the sines totally cancel out. We have root 3 over 2 cosine of x plus root 3 over 2 cosine of x. So when you add them together, that's just root 3 over, just the square root of 3 times the cosine of x. If I were to divide, we get the cosine of x is equal to 0, and that's how we get our two solutions. Number 6, there was a lot involved, and I had a number of people whose work didn't match on this one here, particularly in the interval up here. When we're looking at the interval, again, we got to follow our order of operations. I am subtracting 5 pi over 3 from all of these first. So 0 minus 5 pi over 3, we get negative 5 pi over 3. But then we are multiplying by that 3 in front. So negative 5 pi over 3 times 3 gives us negative 5 pi. Over here, if I'm doing 2 pi minus 5 pi over 3, that'd be 6 pi over 3 minus 5 pi over 3, or 1 pi over 3. But then times 3, notice, just gives me 1 pi. So when we're going through our answers here, again, I did the where is the tangent -1? I started with 3 pi over 4 and 7 pi over 4, just like most of you did, but not both of these are not in the interval. 3 pi over 4 is, but 7 pi over 4 is not. So we know we need negative ones because we want to go all the way to negative 5 pi. So I subtracted 2 pi. So I kept subtracting 2 pi until I got out of that, or I got something that was smaller than that negative 5 pi out of that interval. So negative 21 pi over 4, that would be negative 5 1/4. That was, too small, so I stopped there and really had 1, 2, 3, 4, 5, 6 different numbers along the way there. Then I could multiply by 3, and then I could add 5 pi over 3, and that's how we got all 6 of those answers. Number 7, looking at this one, if I can move it down here, probably the biggest mistake, and I was actually kind of surprised at how many people made this mistake, was in taking the square root of that secant. When you take the square root of the secant squared, it is plus or minus. plus or minus right there. So that means the cosine of x isn't just 1/2, it's plus or minus 1/2. So most common mistakes I had were in only giving half of the answers and forgetting that it was plus or minus there. Number 8, this one was another one that was tricky, particularly in the interval. So if you look at mine, it's a little bit sloppy here. If we look at my interval, this is my interval work here. I added 3 pi over 4 and then I multiplied by -1. Now here's the key. When you multiply by -1, multiplying by a negative flips those inequality symbols. So that means it's really, and you'll notice I wrote an extra line of it, -11 pi over 4 is less than all that stuff in the middle is less than or equal to the -3 pi over 4 over here. So again, I had to flip those inequality symbols because now really I want just these negative numbers between here. So I started off thinking, where's the sign -√3 over 2? That's at 4 pi over 3 and 5 pi over 3. However, neither of those are in the interval. So we knew we needed some negative ones, so I subtracted 2 pi. When I subtracted 2 pi, unfortunately, neither of those were in the interval. -2/3 is bigger than -3/4, so that's not in my interval. So we had to keep subtracting again, and both of these then now were in the interval. If we kept going, it would be smaller than -11 pi over 4, so I didn't keep going. It was just these two answers right here then. So then we multiply by -1 or divide by -1 and subtract 3 pi over 4, and that's how we got that answer of A. All right, last two. Number 9 was a commonly missed one. I didn't necessarily make a lot of comments on it because I think it was a little bit more straightforward once you know what the answer is here. Most of you were good at going through and factoring it. Some of you use quadratic formula, which is totally fine, but we get, either way, we get cosine of x is -1/3 and cosine of x is 2. Cosine of x cannot equal 2. That's, cosine of x can only be between -1 and +1, so we don't have to worry about that. So really we're just looking at this part here. Now here's the key on this one. A lot of people had the right picture, but picked the wrong answer. A lot of people said it was pi plus 1.911. If you think about that as your answers, that would put you into quadrant 4 if you're taking pi and you're adding something that's big on the way there. So if you think about this one, I'll draw it even bigger. I don't know if that helps or not. A little bit sloppy, but 1.911, that brings us somewhere over here, probably not that far, but somewhere over here in quadrant 2. That's what we're thinking about. We know the other place where the cosine is negative would be in quadrant 3. So it's not taking, if you did pi plus that, that would go all the way over here, and we don't want that answer over there. We want this answer. So we want to know this. But what we need to think through is this part right here is -1.911. So really we have to take that value and think about 2 pi adding on to that. So you could do 2 pi, I did 2 pi minus that value, or -1.99 plus 2 pi, it's the same thing. Again, that's what would bring us into quadrant 3 over there. Last one was pretty good, I would say. Most of you realized we needed to think about it as the sign, and that's -1/4. So the only problem here is a number of people did answer with the -0.253. Now, I know that's what our calculator gives us, but we want our solutions to be between 0 and 2 pi, all of them. That's not between 0 and 2 pi. So again, that would be our negative answer here. We want the positive answer, so we want the number that goes all the way around. That's why it's 2 pi minus that 0.253, or -0.253 plus 2 pi there, same thing. Now, again, that is our reference angle on that. That is the distance away from the x-axis. So that means that's the same distance right here. So that 0.253 is that little itty bitty distance right there, and that's why we could take pi and add that. Again, that's different from number 9. Number 9, we did not know the reference angle. Could you figure out the reference angle? Sure, and do it a different way. But again, we didn't know it in that one. That 1.911 was not our reference angle. That's why that one was a little bit different. So check your answers. I know the email didn't release the multiple choice on there, like your actual what you responded, but check your work, check the PDFs or the picture files that you guys posted up online and look for my comments. And of course, as always, let me know if there's any questions on it. Okay, bye guys.